How do you guys feel about the 501 midterm coming up?
Pretty good, except this electron transport chain.
I have no idea why this lecture was so hard to understand.
I have no idea what's going on. I just had my headphones in the whole time.
I'm not even sure what's the difference between a proton and a protein.
Honestly, you guys, I've just never been good in geography classes.
I was pretty hammered.
I wish the information would just come to us somehow.
Ryan, touch it.
I'm not touching that. You touch it.
Fine. Secrets of the Electron Transport Chain.
Who wrote it?
Mitochondria?
Chapter 1. The Endosymbiosis Theory. The endosymbiosis theory suggests that the major components of eukaryotic cells responsible for creating cellular energy, like mitochondria, were once independent prokaryotic cells. The story is that a lazy prokaryotic cell that was incapable of using respiration to create useful energy engulfed another prokaryotic cell that could perform the process of aerobic respiration. The consumed prokaryotic cell was then considered to be an endosymbiont because it allowed for a symbiotic relationship while living within the host cell. The host cell now has a way to convert energy, and the engulfed cell has a safe environment to survive and grow. This is believed to be the mechanism for how certain organelles are now present in eukaryotic cells, and specifically the reason that all multicellular eukaryotes contain mitochondria that are able to convert and create chemical energy for the cell. Chapter 2. History. In 1948, Albert Leininger was influential in the discovery of the major role of the mitochondria in respiratory metabolism. He described some of the main features of oxidative phosphorylation and other energy coupling mechanisms associated with the electron transport chain. In 1961, Peter Mitchell furthered this work, hypothesizing the chemiosmotic theory, which at first was extremely controversial. His hypothesis stated that the electron transport chain and ATP synthase are embedded in the same membrane. He discovered that this membrane is impermeable to protons. Therefore, compounds involved in the electron transport chain have a mechanism for pumping protons across the membrane to create a proton gradient. This proton motive force then drives the synthesis of ATP by ATP synthase.
Chapter 3. The Electron Transport Chain. The first step in the ETC occurs when NADH transfers 2 electrons to NADH-Q reductase. The transfer of electrons from NADH results in 4 protons being pumped across the inner membrane by NADH-Q reductase. The 2 electrons transferred from NADH to NADH-Q reductase then produce a carrier molecule called ubiquinone, or Q. Q recruits 2 protons from the matrix to form ubiquinol. Soon afterwards, ubiquinol is oxidized as it passes 2 electrons to cytochrome C reductase. The passage of electrons from QH2 to cytochrome C reductase results in a net total of 4 protons being pumped into the intermembrane space. Cytochrome C reductase delivers one of the electrons from ubiquinol to cytochrome C, and the other electron is sent through the Q cycle. As cytochrome C transfers its 1 electron to cytochrome C oxidase, 2 protons are pumped from the matrix to the intermembrane space. The electrons are then donated from cytochrome C oxidase to oxygen, the final electron acceptor, and water is formed.
The process just described results in a higher concentration of protons in the intermembrane space than the matrix. The enzymatic activity of ATP synthase is powered by protons moving along their electrochemical gradient. ATP synthase uses this energy to phosphorylate ADP to ATP. Mitochondrial ATP production is the main energy source for intracellular metabolic pathways.
Okay, well, I get the electron transport chain now.
I get it too.
It was awesome.
I totally understand.
We're gonna ace this.